All right, so for 3.16b, the instructions read solve each system giving the solution set in vector notation. Identify a particular solution and the solution of the homogeneous system. So here is the system. You want to first write it in matrix notation. So you got this here, right? 1 is the coefficient here, 0 y's, negative 1 z, and then 0 w's, so forth, 0, 1, 2, negative 1, 3, and then 1, 2, 3, negative 1, 7. Okay, so the first thing I'm going to do is negative 1 times the first row and then add it to the third row. So the first row stays the same. The first row is going to stay the same as 1, 0, negative 1, 0, 1. The second row is going to stay the same. But now I did negative 1 the first row, and I'm adding it here. So I'm going to get 0, then I'm going to get 2, then I'm going to get 4, and then I'm going to get negative 1, and then I'm going to get 6 here. Now I'm going to do negative 2 the second row, and hopefully I don't get a contradictory equation. 2, negative 6. That's the negative 2 the second row. I add it to the third row. So the second row stays the same. And then when I add this to the third row, I get 0 here, 0, 0 here, 0 here, and then 1 and 0, and 1 doesn't equal 0, so this system has no solutions. And I did not make a mistake. Okay. So then there's no solutions here. All right, let's do 3.17. So they're asking us for the system here, right? Which of the following of these, which of these can be used as the particular solution part of some general solution? So the whole thing is that the particular solution just needs to be a solution to the system. And this question is as easy as just sitting here and finding out whether or not this is a solution to the system. And we can check by just plugging in. So 0, 3, and then minus 5, right? Am I doing this right? No, 0, 3, 0, because w is 0 and it's x, y, z, w. So x is 0, and then y is negative 3, which makes this 3. And then z is 5, but it's 0 z, so it's 0. And then minus 0 is 3. So it solves the first equation. It's got to solve all three. Negative 3 plus 5 plus 0 is indeed 2. And then 0, 6, because negative 2 times negative 3 is 6 here. And then z is 5, so it's minus 5 is going to give me positive 1. So I argue that it doesn't solve this one. Did I mess up? 0, 6 minus 5 is negative 1. So this cannot be used as a particular solution. Then I plug in, then I try the next one. So it didn't solve all three. So then this is not a solution to the system, which means it can't be used as a particular solution to the system. Then now x is 2, y is 1, z is 1, and then w is 0. Let's see. 2 gives you 4, minus 1, minus 0 is 3. So it satisfies the first equation. Y is 1, plus 1 is 2, 0. It solves the second one. X is 2, y is 1, this gives me 0, minus 1 is negative 1, and this one is a solution to the system, so this can be used as a particular. Right, and then this one cannot be, right? And then you check also for C. So now let's see C. So x is negative 1 gives me negative 2, plus 4 because it's minus negative 4. 8 is 0 eighths minus 1, so 2 and then minus minus 1 is 3. So it solves the last equation. It solves the first equation. Then y is negative 4. 8 is going to give me 4. And then minus 2 is 2. And then the last one, negative 1 plus 8 minus 8 is negative 1. And this also can be used. And that's how you answer these questions. You just have to check to see if these are solutions to the system. Then they're particular solutions to the system, so they can be used as P.